What's up? It's been a hot minute. Alright, let's get right to it. Yes, coronavirus is going on. Alright, now that that's out of the way, let's talk about what I've been working on since the last video. Working on a folding knife, completely out of left field, but trust me, it's going to work out great. So we're going to work on a fixture plate for the blades right now, and let's go. I made some soft jaws for the handles at one point, so they kind of worked, and now we're moving on to an actual fixture to make these things. But the first fixture we're going to make is for the blades. It's going to be a, well, I'll show you. Yeah. Right. Alright, while the machine's warming up, let's talk about some things I've purchased. You guys need to go somewhere more solid. Things I've purchased for this knife adventure that I'm starting. So I tried making a fixed blade, or I successfully made one, but I wasn't very satisfied with it because I feel like with the CNC you should be able to do something a little more fun than a fixed blade. Not to rag on fixed blades, but it's just a personal challenge, I guess. Fixed blade's a little bit more there's more going on with an actual fixed blade. So I had to buy a ton of stuff. It's obviously modeled in Fusion 360. And then I bought a bunch of McMaster-Carr stuff because there's the insert McMaster-Carr thing on Fusion, and it makes, modeling parts and everything super easy. So we're gonna go over some of the stuff I bought, but over the next coming weeks, we're gonna be going over actually making the knife. So you're all gonna see these parts, but just to start, we got super tiny 440 screws, 3/16 long, nice and tiny in my baggie here. That's good. That's 50 screws, nice and cheap. Then it's all downhill from here. We got, these are 256 screws, very tiny. These are 1/8 length. Good times. Those are to hold the frame on. It's a frame lock, so there's no handles. Here's our ball bearings. This is for the lock, or the pivot. Yeah, pivot lock. See, I'm new to knife making, so oh no. Some more hardware. These are the I forget what the type of bronze is, but they're basically for the that's going to be a frame lock knife with bronze washers, and they're like the fancy ones with the impregnated whatever, I don't remember, but they're actually not too expensive. I bought them off knifekits.com, I think, and they shipped it out really fast, so that's pretty cool during these trying times. And the final most important thing is we bought a new lathe, and let me just get it out for you guys. Here it is. This is our lathe to make our pivots. I mean, yeah, actually our pivots and all that. So, and all joking aside, this is a ER32 collet block. So what you can do is take a collet and jam it in there, and then you can stick round stock through there, and then we can mill it like, like a poor man's lathe. So that's my solution for round parts for now, until I can be super successful, pull a Grimsmo, and buy a lathe. Okay, let's move on to actually doing something. Alright, here's what we're going to use for our fixture plate. It's a 4x2 6061 T6. I need to cut it down to 8.5 so it fits lengthwise in the vise. And yeah, let's go. Check this out. So this is a new mirror tool, ER11 3-inch long holder. Look at the end though. It's so tiny. It's a 1/32 end mill. So obviously, 30 thousandths in that area. So I need that to cut the frame, the tab for the frame. You'll see. You'll all see. I cut myself again. I can't believe it, on the same finger. Okay guys, sorry for the out of screen video, but I just finish this real quick, so I'm kind of in a rush because it's kind of late. So adapt to the outside, contour, face, drill, then quarter inch 20 form tap. Yeah, adaptive clear the inner pockets, do all that. Contours, 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 contours. Steep and shallow for the ramp for the blade, chamfer the round side, outside, and then trace the mark. And let's go. I thought we were hitting the holder, but it's actually because the flutes end here, so it had chatter here, and that's why I was making that loud noise. So we're actually going to face it first, and then I'll do the final contour round. Okay, I had like a weird error before tapping, which is always scary, and it was like H and T not matched on the Haas control, but that's because the length offset in Fusion was set to 22 and it's supposed to be tool 23, so I'm thinking that's it. Nice and easy. Okay, I had an issue with cutter comp, but I realized it's because I use wear in Fusion 360, and you can't have a tool diameter in the Haas control if you're using wear, so you just set it to 0 and then you use your wear compensation that way. Let's go. That looked good. Yeah, boy. Hey, what's up, people? It's day 2 of our knife making adventure. So I had a weird issue trying to probe the fixture in. with the probe. Like I would probe this corner, in this inner corner, and the probe would end up, it wouldn't offset its diameter over, and I thought that was super strange. And I noticed before when I do in the Haas control, like do the vice corner offset, like the automatic offset, it would just say probe not calibrated, and I was like, what's going on? So I ended up getting a ring gauge and then recalibrating it, and that seems to have fixed my issue and the offset issue. So yeah, so off camera I made some clamps, these guys, so they go, one goes in here, quarter 20 goes right in there for the blade backside, and then there's one that goes here when this material gets cut, and then I face down some stock, and we're gonna try it. So I'm kind of nervous, but we'll see how it goes. The tool path should go around our hold downs, and it should be a beautiful thing. So good. Ooh, let's see how this first op came out. Damn, son. Alright, next up is a bunch of boring operations. Boring. Oh, this turned out really good. Ladies and gentlemen, welcome to day 3. Alright, yesterday we got this really important bit done. Very nice, very cool. Actually worked significantly better than I thought. We even got the jimping on the back cut with our 60 thou end mill and the front blade relief. Come on, focus on the task at hand. Okay, I guess it doesn't want to. You can kind of see, I guess it's kind of hard to focus against these two surfaces, but yeah, right there. So that's good. Now we're going to run a little chamfering tool around the edges to get rid of the burr that was left by the end mill. Probably a dull end mill, that's why. Yeah, but yeah, worked really good. Didn't hit the bolts or anything. I put a clearance circle around to the tab. It's like a couple thou, and it worked very good actually. Better than I thought it would have actually. Yeah. So we're chain for that, and then we're gonna kind of figure out. So the way that this system's gonna work is, I made these clamps yesterday. I think I mentioned that. So they go right here, and there's a little step on the bottom of them. Kind of hard to tell, but right where my thumb is, there's a 10th step. I don't think you can see in the camera very good, but that's to aid in like it wanting to force the front end down, and that goes in that tapped hole like so. So in theory, hold on. In theory, that'll hold the blade down while we then cut the tabs off, but I have this sneaking suspicion that this clamp is either not going to be enough to cut the tabs, or if for some reason you put the clamp down and then bumped it, well, you would lose your position for the tabs. So I definitely need to come up with some sort of dowel pin or something to hold the blade, just that extra bit of hold down. And something just came to mind as I said dowel pin. We could put a dowel pin right in the pivot hole, because the pivot hole is 3/16, and I have 3/16 dowel pins. Let's see if one of those pins fit. Side note, a little side project. That's not supposed to do that. See, the bed leveling is working great. Okay, I guess we'll stop that for now. Onto the real boys machining. So we got our 3/16 dowel pin. Oh, actually that worked pretty good. Because it goes in there. I might have made the pivot too large, because these are definitely, they're pretty tight tolerance pins. Okay, so I think while we have it set up, why don't we go ahead and bore this hole, this 3/16 hole, all the way down, and then that, at least that'll give us that dowel pin thing, and then just as a like a extra safety to keep it from moving. So we'll do that chamfer, and then we'll bore out that dowel. All right. We chamfered that thing, just got the burr off of it, that's cool. Now what we're going to do is take tool 2, which is a 3 flute 1/8, and we're going to, like I said, go down in this hole and bore pretty far down so our dowel pin fits. And yeah. Alright, the boring went good, so I didn't hit the tool on the thing. I thought I was going to. It was really close. So that's it through the blade, but I left some stock in the actual fixture plate, so we can dial it in to be perfect, because obviously you want you only have one shot to cut the fixture plate, so it doesn't go in yet, but we're just gonna basically use wear and comp it over until it fits. So yeah, but I'm gonna take some pins, gauge pins, and see which ones actually fit. Alright, so I just checked it. Even a 1/8-2 pin doesn't fit, so oh, that was loud. I set up a contour toolpath, and what we're going to do is we're going to send the toolpath down in there and then cut a circle using our wear offset, and that's going to be diameter wear here. And to start, we're going to do -2 thou, which is going to actually take the contoured circle, the toolpath, and then push it out 2 thou. And so you're comping for like the actual tool diameter, and we'll just comp that out until the gauge pins fit, and then we'll check if our dowel pin fits. So that was a 2 thou take. Let me grab the actual gauge pin. So our gauge pin actually fits in our pivot hole, so we know that the pivot hole is actually oversized, because it's supposed to be 1/875, and it fits. I'm guessing 1/8/8 fits as well. So I'm going to say another 1, so that'll give us the 3. Definitely want to walk this stuff in. You only have one shot. So 1/875. So there you go. Might even be too much. Let's go take the 8/8 pin. 8/8. Yep, 8/8 fits. Kind of. Not really. Doesn't go all the way down. So obviously the hole's got a taper to it. And here's 8/9, which fits in our pivot. So obviously the pivot's been overcut. And the reason the pivot's overcut is because yesterday I didn't realize there was a -5 thou wear comp in the control. So that's probably where our issue came in. So this pivot, this blade might actually have a lot of slop in it when we go to do final assembly, but that's okay, because this is all part of learning, you know. So yeah. So there you go. So now in the future, what we can do is take our stock and we'll cut our 2 holes and a precision hole for the dowel, and that way the stock is always going to be dead nuts to this feature as well. And also when we clamp it, now the blade has a actual locating pin. The only issue with this is there isn't a dowel pin here, which would be the best way to do this in this hole. That way you could have two locating features, which leads me to wonder. Hold on, I got an idea. Okay, now what we're going to do is, as I was talking about, I'm also going to make a bore for this hole too, because this is 1/4 inch, and I don't have any dowel pins. I have obviously the gauge pin, but you probably don't use those too often, or as often. And so here's a 1/4 inch end mill, a very expensive end mill that I broke, and that'll fit. Again, the hole is kind of big because of that wear comp from before, but we'll again bore the fixture plate out, and then we'll have two really nice locating features we can use for the future. So yeah, let's model that up and do it. Alright, so here's the plan. We're going to use a 3/16 floor flute to bore down into the plate 0.4 inches down, and the tool is going to hit this bolt, but what I'm going to do is we're going to take our clamp and then we'll clamp here, and that should give us enough rigidity. It just barely touches, it won't touch the clamp, it's like just barely above it in simulation, so that of course means it'll work, but it does hit the bolt head. So like I said, we'll clamp it down, remove the bolt head, and bore it out, and hopefully that works. And then we'll do our wear comp to get a pin to fit. Hey, it turns out I'm kind of dumb. So I made these clamps, right? And the whole point of a clamp is to, clamp material down. Well, if you notice that step I was talking about earlier, well, I put it on the wrong side. So instead of clamping, downwards, which I wasn't thinking, they clamp towards the bolts, which are, mostly behind it. So it wants to pick the block up, and I want it to push the block down. So, oops, see, there you go. It's the universe trying to tell me something. So instead of it going down like it should, it does this. So that's a failure. So I got a new clamp, right? It's contained in this block. So we'll make a quick one. I will test it, and then we'll make a whole bunch of them, because I wasted the time making 4 of those, of course. Okay, so we got 2 of these guys cut. Now I'm about to do the op 2 and just face them off below. So yeah, pretty little clamp part. I'm not sure if aluminum's gonna work long term, but this is all prototyping, so it's all good. So to do op 2, the actual facing, what I did is I got some shorter parallels, and the parallels sit right up against this lip here. And then the entire vise grabs this entire edge. That's why I had to use the shorter parallels. And then yeah, so that's how I'm doing up too. Something you should think about if you're going to machine parts and have complex geometries. Originally when I made the clamps, I actually had them round, like on this front lip, to match the curvature of the blade. But then I was thinking that's a terrible idea, because then I'd have to make soft jaws to do up too, and I'm lazy, so that's why they're straight. So it's just a simple face with a 3/16 tool. Pro tip, so I put the G55 point in the wrong spot. See, there's this hat on the part left. Obviously it's supposed to cut the whole, there's obviously supposed to not be a hat. I set the bottom point is to the parallels. Well, the bottom of the part is not resting on the parallels, the lip is resting on the parallels. So here's our part. The part is actually resting here and not here, so obviously it thinks the part is actually taller than it is supposed to be. So I just updated it and sketched the point between this midpoint on this plane, and that should fix our problem. Or crash the machine. We don't really know until we run it, so yeah, let's crash the machine. Let's see your big cuts. Perfect. So obviously that step was a 20 thou step, because that's how tall the step is that it's resting on. So yeah, pro tips. Real pros. Alright, here's one of the done clamps. For some reason my heights are off by like 2.5 thou, which I'm trying to figure out, so I just remeasured the cutter. So I'm going to cut another one and see, but before we do cut that, let's make sure the new style clamp, I mean the style we had all along, you know, actually does something. Well, I saw it move down, so that must mean it works. What I should do is extend the block out like this way and put that foot farther back. So like bring the block this way a little bit and then extend that foot, and that would give us a better, more leverage, because obviously the bolts are right up against it. So yeah, I think I'm going to do that right now as opposed to fixing it in the future. Might as well fix it now. But this does work, so that does prove that that's the proper way to do that. Like anybody, obviously everyone knew that, except yours truly. So here's the new and improved clamp. You can see the body's a little bit wider on the back, giving the, you know, that more leverage. Seems to work good. I made 4 of them, and they're all dead nuts on height. I'm not sure what the deal with the height was, but it seems to have fixed me retouching it off the tool setter, so you never know, it might have moved in the collet or something. Who knows? So now that that very long 5-hour debacle is over with, we can continue on to doing this. So let's see. I ordered some dowel pins from McMaster-Carr that are 1/4 inch. We bored that hole out. Wait, did we bore that hole out? Oh no, we haven't even done that. Okay, so we're gonna bore that hole out now, and yeah. Nice and tight. Okay, now we will bore. Guess we'll stop it if we hear bad things. Okay, so the 250 doesn't fit. Here's the 245. That fits. 247. That's tight. 248. That fits as well, and very tight. 249. Barely goes in, so we'll just comp out 1 thou. 249. 250. It works. So, 250 it is. Alright, so that's a good. Now what we need to do is I need to figure out how to cut my end mill to fit in here. So we don't hit it when we do the cutout. And yeah. Alright boys, you ready to try this? So I'm going to take these two out. She's clamped down. That's going to stay there. I don't have a pin that'll fit that because my end mill can't really cut that with anything that I have. Yeah, and then we're going to cut the tabs off and hopefully it all goes good. What could possibly go wrong? Nothing. Here we go. I don't think the clamp is over there. Huh. Interesting. Cut over here, boy. Okay, I had G54 set to the center of the fixture block, so obviously G54 is supposed to be this inner corner. Now we will try it. We did it! Very cool. Oh, you know what I can do now? I can come in and chamfer this. Ooh. Yeah, I'm gonna give that a shot. Alright, let's try that chamfer out. You guys can't see anything. Alright, trust me, it's gonna happen. Oh, that worked really good. Beautiful. No burr to speak of. Except maybe on that corner. Oh well. Man, this worked really good. That's awesome. So the dowel didn't even move, so that's a good sign, because that means the clamp actually held it down during that cut. So that's a good indication that these clamps work. There you go, there's op 1. Very nice. Just a tiny little burr from it. Cool. The backside didn't come out as good as I wanted facing yesterday, but it's all good. Alright, let's see if it fits in its up 2 spot. Yeah, let's put the really expensive camera in the wet environment. Oh, so close. What is your issue? We'll just cut this off this little bit and flatten it, see if that works. Yeah, that was way harder than it needed to be. Oh, it doesn't fit in that radius right there. Yep, that's definitely what it is. Okay. Okay guys, I have run into the single weirdest issue and I cannot seem to figure out what is going on. Okay, so we know that our blade stock fits in this pocket, obviously, because it's in there. There's a very tiny amount of wiggle, but with the clamp it'll hold it right in place. So this blade stock is not the correct depth. I know this because I measured it with micrometers, and that's like 115. That's 10th away from where it's supposed to be, which is 125. Now that's probably because I messed up cutting it with the stock, but that's like an aside. I only noticed it because the bearing pocket wasn't cut on the other side, and I went, that's weird. So now the question is, why is this, like, I'm making sure the pockets and everything are the right depth. Why is it that this dimension to this dimension is correct in the model, this dimension to that dimension is correct in the model, like this dimension to the flat on this part is correct in the model? So I don't understand where that 10th thou is missing when I measure. It's kind of hard to explain. Hold on. So this dimension to the bottom of the pocket is supposed to be 125 because, well, that's literally the height that, you know, it sits in the pocket. So if we measure with this, I go down, 1, look at this, look at this, that's 1 and 26. How is that possible when this measures 115? What is going on? Okay, I will figure it out. I've been trying to figure this out for 30 minutes, and then I will get back to you. Okay guys, I've come up with a solution for my problem. I'm gonna do absolutely nothing. Now, the reason this is such a fantastic solution is, one, we still get to see if the plate works, and in the future, when I actually cut this properly to 125, and a problem rears its ugly head, then we will know what caused this problem in the future. So yeah, and this video is probably very, 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 very long. So we're gonna cut this part, prove that this whole setup works that I've been doing for the last 3 days, and post all the modeling time. So, and that'll be a good introduction to this this knife series I guess we're doing. So yeah, let me clamp this up. We'll let her eat, and then I will go inside and spend multiple hours stringing all this garbage together. Alright. The clamp barely clamps onto it because obviously I modeled it with a little bit more material, so I think we'll be okay though. So it's got some bores to do. It's got a bore at the bearing, or the pocket, the washer pocket, but like I said, it's supposed to be 10 thou, so the end mill might not even touch it. That's why I didn't touch it on the other side. And then it's going to do an adaptive to cut the majority of the blade section, whatever you want to call it, and then it's going to come steep and shallow with the ball end mill. So we'll see. And nothing hits in simulation, but we all know how that works. So yeah, let's do it. Contact! Alright, here's what we won. Hell yeah, boys. Rough on the bearing pocket for sure, but I don't think you should be using a 3 flute, is probably why. Oh, that's sharp. But, blade portion looks nice. Really good. Really good. Alright, one last thing. We're gonna chamfer just the edges we can hit, and hopefully not the clamp. That made the pocket look really good. Didn't line up very good. That's not a good sign. Oh well. Oh, perfect, okay. So, welcome to the end of the video. Here is the back side. Check this out. So, some things to note. This thing I was complaining about mere seconds ago. See this chamfer right here? Come on, focus. This is really important. Alright, see this little lip? Yo, now you see it. There's some sort of mismatch with the chamfer, which is super strange. And then, see right here, in this little gullet, whatever you want to call it, the ball end mill cut up here for some reason. And it's not a simulation thing, it's not a software thing, it's something to do with the way the fixture is set. So, yeah, I don't know. Sorry, my wrist is itchy. Yeah, it's super weird too, because this bore right here lines up, best I can tell. And this, what do you call it, the pocket for the washer seems to line up too. So, yeah, I don't know. Kind of weird. Might have something to do with my weird height thing. Something I did realize is this detent, where the detent ball will ride into. See right here where my finger's pointing? It needs to be like dead nuts on, and the fact that I have it flipped over and in op 2 or op 3 to actually cut the hole for the detent might cause a problem when we go to assemble the knife. So that's something I'll be dealing with in the future. But other than that, it came out pretty good. I need to cut out a new piece of stock 125 and actually make sure it's 125 when we start, and that'll give us a good indication that everything will work pretty good. And now that we've done all the toolpath work, we should be able to fly through another one. So I probably won't film that, but I will film the next part, which is making a handle fixture. So that's going to be pretty complicated, and cutting handles. So yeah, my plan is for this thing is what's the word? What's the type of steel? S30V. Hold on, let me look. S30V. I knew it. See, that's what I meant. So S30V, which is the stainless, a pretty high quality stainless blade steel. And then we're going to do titanium handles because anodizing stuff is cool. So yeah. Yeah, if you want one of these knives, well, you gotta wait because they're not ready yet. And yeah, that's pretty much it. They will be for sale though, whenever this happens. Probably be a couple weeks. Alright, yeah, if you like this stuff, do the like and the subscribe and the... Oh, if you want to follow me on Instagram, it's the same My username's the same, and I post a lot of stuff about this stuff and the machine and that kind of stuff. So yeah, if you want to follow me there, you should. All right, thanks for watching. Hey, before I let you go, I figured out why the that chamfer didn't match correctly. So on the, I'll just show you guys really quick. Oh, that was really loud. On the first operation to, there are tabs, obviously. Focus, manual focus. All right, autofocus. So if we look at the blade's orientation is sitting like this, and that problem area is right here, down on this edge. Well, if you look, our first contour before we cut the tabs off doesn't go down into that edge, and then on the next op, when it's actually fixtured and it does its contour, it uses a different, it's using a different, what's the word? Oh, hello. Where the... It's the same tool, but what happened was between the time I did the first op and the second op, I actually changed the wear offset on the 3/16 the 4 flute. So I'm thinking what happened is it didn't cut enough material, and that's the same reason we have problems with the actual soft jaw down here, or the negative, and it wouldn't fit. It's probably because this is actually oversized. So yeah, so I'll fix that, or we'll make sure it works out in the future. The problem is, like, if I pull this off from that first op, I can't measure this without, you know, going through the entire motion and seeing that something doesn't work. And then the ball end mill part, well, I'm not too sure about that. But yeah, thanks for sticking around, and see ya.